Okay, so Cauchy integral formula for derivatives. So same assumptions as before. We have f of c naught, its nth derivative. Has the following expression, where n is any number bigger than or equal to 0. For n equals 0, we just get CIF from before, right? So it contains the previous result. Okay, so let's prove this. We're going to follow the one from the book. But yeah, if you like, try to deal with Taylor expansion. It's the same argument. So Taylor proof also works. Okay. All right. So we will do n equal 1 case. Okay. So we talked about this. You have delta is equal to 0. This is the C differentiable definition, right? That's how we defined it. So you have Z naught, and you can come from any direction. Okay. We use the Cauchy integral formula. So let me take out delta Z over here. So first guy, yeah, so we have the contour, and then what? We have, yeah, C, and then Z minus plus delta Z. So here we have a contour, right? We have Z naught, and you know, we use our Cauchy integral formula for Z naught plus delta Z. And here we apply the Cauchy integral formula for Z naught. So CIF for Z naught plus delta Z, and CIF for Z naught. Okay, so that's the difference. Okay, yeah. So the goal is to write this claim. This guy is equal to f of z. Yeah, f of z with what? Okay, I forgot the 2 pi I. It will be z minus z naught squared. Okay, so that's the claim. So we have to go from here to here. Fine. Let's do this. So what they do in the book, they start from here and they combine the contours. Okay, so let's see. So you have two ratios, right? But f of z is a common term, so I might as well take it out now. Just to see how they did it in the book. And they do common denominator. Okay? So if you do that, let me divide by delta z to see how they get the cancellation. Right, so we have So we have z minus z naught minus z minus plus delta z, same and f of z. Okay, almost there. So yeah, these two cancel out. And you just get minus delta z. And this, okay. Now, why is this important? It's important because we get a cancellation. So delta z cancels out with this delta z. So all in all, we are left with this. Okay, and the claim is that this is about f of z, z minus z naught squared. Okay, that's the claim. Okay, let's continue. Okay, so we're going to prove this claim. So in the book, they take their difference. Okay, so take their difference. Okay, so we have f of z over the desired formula and f of z minus the thing we want to get. Okay, so we have this. Same thing. Write down the write down what it gives you. Okay, so do common denominator. And same as before, you get minus delta z. And this term. Okay, so we cross multiply. All right. Again, do deformation of contour. So we have c minus z naught equal to delta. Okay, and same stuff. So yeah, do deformation of contour. So this is z naught, and over here we have z naught plus delta z, and this is z. So do deformation of contour and take delta z to be less than delta over 2, so that any poles are inside. So both poles inside z minus z naught delta. Okay, so that's why they take this to be less than delta 2, to ensure that both poles, this pole and this pole, are inside. Okay, so both poles z naught and z naught plus delta z are inside. Okay. All right. So again, we do ML inequality, meaning what? We bring in absolute value. So okay, all right. We already know what this guy is. This is just delta squared, right? Um, f of z is continuous. So by the extreme value theorem, um, the absolute value of f is less than some constant m. Okay, and c minus z naught less than delta. If you have questions about this, please let me know. Okay, so that replaces f. Okay, we still have delta z, and we still have this difference. Okay, now let me explain how do they estimate in the book the very last term. Here you do what is called the reverse triangle. Okay, so let me write in a bubble. If you have a minus b, you can do the following: a minus b. So you have this bound. So triangle inequality says this is less than a plus b. Reverse triangle says that you can bound by the difference. Okay, all right. So we have this guy, and then minus delta z. Okay. Right. So the first guy is just delta, right? And this guy is less than delta over 2. So delta over 2. So we get this. So let's retry. What do we have? We have m. We have delta 2. The delta z comes outside. And yeah, so we also have delta 2 over 2. We're almost there. Okay, so we have m delta 3 over 2 delta z times whatever this is. This is the length of the circle. So pi 2 pi delta. Okay, so all in all we have delta z and 2 pi delta square over 2. This is a constant, and this guy goes to 0. Okay, so we proved that f of z, z minus z naught squared, is the limit of this. And we showed above that this was nothing else but f prime z naught with 2 pi I. Okay, so that's it for proofs. Next we do